Buck.
I hate my life.
Okay, so that's good enough. Thank you. Um, so we're gonna take a few notes. We're gonna post this online for them to watch, so they can see. So we're gonna talk about surface area and volume in this unit, but there's a few things I got to get out of the way, and hopefully I can stick to this as well. I don't know if I can, but here's some good vocab for you. So almost all 3D objects um, that we study um, in this chapter are solid figures made up of flat surfaces that are that enclose a region of space. They're called polyhedrons. So it's funny because I could have just said, yeah, these are just 3D objects, right? But 3D objects can be curved on a side. There are ones, and notice I said almost, because there's ones that are curved called spheres that we're going to look at in this unit. So most of everything in here are called polyhedrons, and that means flat surfaces that enclose a region of space. Okay, and that's a technical name for it. I bet you I won't even say it again, except for today. These flat surfaces are called faces, not feces. That says faces. I'm sure I'll get a parent contract for that. Um, so you will hear me say faces though, because I can't say sides because depending on how something is orientated in three-dimensional shape, sometimes sides might be bases. Um, so the first type of polyhedron um, that we study are called prisms, and prisms might make you might make you think of something funny or optical, but it's just something defined like this. They have two parallel slash congruent um, bases called bases. Faces called bases. But in order, Logan, stop. In order for you to, because I can always play this for your mom too. Don't forget. Um, um, blank blank time. I didn't pause it yet. If I say what's the base, you're looking for two parallel congruent faces. Okay. Um, these bases are connected um, by parallelograms called lateral faces. I don't know how much you'll see lateral faces in my vocab, but you will say lateral. you'll see lateral area in a lot of math classes. Okay, so we have polyhedron, faces, prisms, bases, and lateral faces. So the same time, at the same time, we will look at or study cylinders with the Y. They're actually prisms that are circular. Um, they have bases that are circles and one lateral face that is curved, which is maybe not as curved as you might think in a little bit. Here is an example of a cylinder. I cut it out of the internet, and bases actually didn't fit in those holes, so I had to cut them off. But cylinders actually have two bases right on the ends, right? It's like a pop can or a soup can. I'll come back to that in a minute. All right. Here's a couple of things. The problem with these three-dimensional objects is that unless you look at something like this, um, they're two-dimensional, right, on a piece of paper. So you kind of have to draw them isometric. Depending on how good you can do that, I can do it somewhat good. Can you? So there's a box, like a Kleenex box, right? Um, Cylinders kind of look like this with a optical looking circle, and then the bottom's curved like this, but then on the bottom we usually draw a dotted line because it's behind that stuff, right? You can draw, and you guys will probably have a little bit of trouble drawing these. I don't even really want to try it, but you have to draw like pentagonal ones sometimes in examples, depending on how good you are at it. Some of you are even better artists than me. That one might look like a drum or something. So what can we do with three-dimensional objects? We can find surface area and volume, but we're going to do surface area first. Surface area is defined as the sum of the areas of each face, and that includes the bases. Because bases are faces, they're just parallel and congruent, right? You have to define lateral area because you might see it on the ACT. I should probably keep this straight so fifth block doesn't have to tilt their heads. Lateral area, we will not find lateral area in this class, but you have to know what it is. The lateral area is area of just the lateral, that's the word that, lateral faces. It's just the sides, not the top and the bottom of the box. So